Do we have a question from the audience?
So thank you for these very interesting talks, and I immediately have an application in mind for the knowledge that you guys are building on. So from the perspective of the Astrophysical Lunar Observatory, the radio facility we hope to develop on the lunar far side, we are very interested in the interaction of low-frequency radio waves with the different regolith layers. And so the work that has been going on with the ground-penetrating radar on the Chang'e 4 rover is very close to this. Do you know of people who have modeled the general interaction of EM radiation at these long wavelengths with these regolith layers in some detail?
Thank you for the question. I know the problem. No, I don't know. So I cannot answer directly, but as a general thing, they're quite different, the two techniques. So yes, obviously both exploit electromagnetic waves and signals, but they are quite different. So like on the Earth, basically. So the problem is that obviously lunar penetrating radar, as any ground-based data, has a limited length. Even a few kilometers, it's very, very small compared to other remote techniques, for sure. Thank you.
You have another question here in the middle?
Thank you. I guess in the first speaker's talk, you showed velocity analysis and quite a bit of variability, and then all of these different layered units in the next two talks. How much does the velocity change between these two layers, and how much would doing a migration help with maybe the interpretation of putting these things in the correct depths?
Okay, the data I presented is preliminary. It was done using an automatic algorithm. Actually, is a paper with Manuel as well. That is in revision now. That was for the first 150 nanoseconds. So basically the 12 meters of the regolith. We found that in the paper I mentioned before that is published on Science Advances, we find that using some algorithms to migrate the data was impossible to migrate the data. And we had to use tomographic reconstruction interpretation. The reason is probably that in that condition, the radiation pattern or the cone is really large. And what you see also blocks like a large block, like 1, 2, 3 meters, you see almost flat. Okay, so the algorithm doesn't catch, doesn't refocus probably the data. So it's difficult to use migration to calculate, for example, the velocity, because this is another way you could do. So in any case, the data you've seen has to be filtered out. That all the possible. I purposely, you see there are also lots of big uncertainties on this data, so has to be filtered out, and so to create a profile. Okay. In the top 40 meters, you pass from, but the bottom you can't check. The first 12 meters in the regolith, you change from 0.20 more or less to 8 or 18 to 0.12. Okay, so you move from, let's say, 2 in permittivity to 6, just to give an idea. Okay. Sorry. It's probably due to compression, but a 6 is still, it can be a rock, but might be also dense sand, okay? So it can be very little porous sand.
Prashant Mohanty, Arizona State University. My question is for the last speaker. Thank you for the nice talk. One question which I had is that you mentioned there were like 100% scattered. So what did you really mean when you said 100%?
that the total amount of insolation received by the illuminating part of the crater is reflected to the other side part of the crater. So you have, it's like you have the 100% of the scattered light. So what you see in shadow actually is illuminated by the backscatter radiation. This is the meaning of the 100%.
Okay, so but you don't mean that 100% of whatever light came in got reflected?
Yes, it's exactly what I mean.
Like the entire magnitude of that light got reflected?
It's the 100% of dramatic, yes.
Okay. The other question which I had is that, so you spoke about the modeling of the pits and lava tubes, like in your final stage, when you're talking about a COMSOL modeling,
Yeah.
what are you basing that model on? I mean, do you have like DTMs or are you going to base that on an Earth kind of modeling?
In first place, we are using synthetic 2D and 3D model. Then we will move to LROC DTM. And we use spice kernels as inputs. So no, it's not Earth-based, but it's in first place synthetic, and then we will move to LROC data.
Okay, but for lava tubes, what kind of DTMs are you going to use?
No, for lava tubes, just synthetic.
Okay.
No, we will play with depth, lengths, latitudes. This is, of course, just synthetic. Yeah.
Thank you. Yes, I want to continue on this topic because I'm curious about what is the confidence about the geometry of this kind of structure. So did you run any sensitivity analysis about how the geometry is modeled, and what is the usual confidence about this type of
I'm
structure?
actually running confidential. I'm trying to understand which are the best geometries. As I said, it's just the starting point. We started with the simplest one, and then we are complexing a little bit the model, but actually we don't know exactly how to so far how to model them.
Okay, do we happen to have a question for the third presenter, or shall I ask one? Matteo?
So yes, my question is, it was, I think, really interesting, this relationship between the topography and the deep structures that you have seen. And actually, I have two questions about it. The first one is, do you think that this kind of depression is due to some structural deformational features like graben? It's the first question. The second question, if, I don't know, for everybody probably, if there are some, for the planning of this path, are plans to go through the features in different directions or twice in order to have a 3D geometrical reconstruction of these features, even on that? These are the two questions.
Okay, thank you for your questions. I can answer for the first one. Maybe for the second one, my colleague have some more detailed ideas than I have. But for the first question, I can say that we sometimes very often we associated this low depression to craters, impact craters. As a matter of fact, we were very, very lucky that the rover crossed just one of these low depression areas, and we associated this depression area to an old buried crater, which was unit 1 and unit 2, described by Professor Forte. And maybe we can get more confident on this relation with the following release data, because just one low feature was crossed by the rover. So this is just a very high confident hypothesis. So we are looking forward to confirm it with the next data release. Maybe with the data released last night, we can see something else. For the second question, have you
Yeah, it's a very interesting question. Unfortunately, we are not involved in the Chinese mission, so we are not able to decide how moving the rover. And just to joking, I can say that they try to avoid the most interesting places. No, I'm joking, obviously. But the problem is real because they avoid the steeply topography, they avoid blocks, they avoid the rims, possible rims. So, the best, this is much more geophysical, but basically you should cross perpendicular the structure. While this is the most difficult logistically thing to do on the moon, so they try to avoid that and they just follow the border, and that is not the perfect way to extract geophysical data. By the way, even for the migration, this is a problem because the line is crooked and they have turn around, they stop, and there are many other specific problems on the data. So before processing, you need to eliminate some portion and you need to regularize and smooth a little bit the path because otherwise it's not possible to migrate the data. So to obtain the real shapes. One interesting thing is that the vertical exaggeration on all the pictures shown is very, very high. So the ratio between horizontal and vertical scale is very high. And the maximum dip found it's lower than 15 degrees. And in that conditions, as far as the reflector, it's not so important to make the migration, to image the data. While obviously for the diffraction, it's very, very important, as Elena told you before. By the way, I'm happy that this session it's dominated by the women, so the gender balance is toward the women, and I'm very happy for that.
Okay, thank you everybody for a wonderful session.